Hello, everyone. So in this problem, I want to show you how to use salt uh, to get your correlation and then also to get your scatter plot or your scatter diagram. So here you have your table, right? And we're trying to find how much should a healthy Shetland pony weigh. Your X is the age, and then that is in months. Your Y is the average weight in kilograms. Okay. Now, here with your scatter diagram, I mean, you could check to make sure that you choose the right scatter diagram. You don't need to go to salt to find that. So if you look at the X values, as the X values increase, the Y values increase. So this has a positive correlation, a positive linear correlation. So this is going up. So maybe it's the first one. This is going down from left to right, so it's not this one. This is going down, no, this is going up. Now you've got to check your value. So the first one is 3 and then 60. 3 for X and then 60 for Y. The second one is 6 and then 95. So you've got 6 and then 90. Let's see. So this is 80, 85, 90, 95. Wow. So 6 and 95. I've got 12, which is 11, 12, and then 160. 12 and, oh, 12 and 140. Oh, yeah, 12 and 140. Okay. 19 and 160. Oh, yeah. 22 and 177. So this should be somewhere there. Oh, yeah, that's good. So right there, I know that it is this first one. So I choose that. Okay. So here, what are you going to say about the correlation? Is it low? Is it moderate? Is it strong, positive, or negative? And you should be able to do that one. And then now we have to find our correlation. Now, our correlation, the value of it would also tell us if this is a strong positive or a weak positive or a uh, uh, moderate positive. And we did that in class as well. And then you could also look at it from the graph if you decide to draw a line through. All right, so let's go to R real quick. Now I'm trying to find R. I don't want to use the formula. I want to use salt for it. So I go to salt, use salt, and then it's going to transfer the data for me. And then I'm going to go on to regression. And then it says select my variable. I know that my explanatory is X, and then my response is Y. And this gives me what I need right here. So if you look at the scatter plots, you would see that, oh, this diagram looks like the one we chose, right? Yeah, it looks exactly like that one. And then you come here to your correlation. So I've got a 0.9741, 0.9741, which is close to 1. It's close enough to 1. So I say that this is a strong positive correlation because of the value. All right. And this is our R squared, and then our F statistic, our degrees of freedom, and then what have you. And this here at the bottom, you have your summary. So you have your intercept and then stuff. But for right now, we want to look at the R value, which is 0.9741. All right. Now I'm going to quickly move on to number 16, another one. And this is all lesson 9. So I'm going to go back. to 16. Where are you? All right, there we go. So here also we have X to be the age of a licensed driver in years. Okay. And Y is going to be the percentage of all fatal accidents. So due to failure to yield the right of way. So this is what we have for our X and Y. Now, I have to find the graph. Again, you could just look and then get the graph, or you could go to Sol to find it. So I'm not worried about that one. Now I have to find my X bar. Remember, X bar is the mean of your X values. And then also Y bar, which is the percentage, that is also the mean. So you could do that without going to Salt, add all of them and divide by. So add X values. There are 6 of them. Add and then divide by 6. For Y bar, add all the Y values and divide by 6. Okay? All right. So if we do that, if I want to do that on a calculator, add all the X and Y values and then divide. So that should give me, probably I'll just use salt because I just want to show you what's going on. So let me go to salt. It's going to transfer all the data values for me. Done. And then go to that. Now, first of all, for X bar and then Y bar, I could always go basic on this, go to descriptive statistics. And then look, I've got 62 for my X bar, the mean, and then 19.1667 for my Y, the percentage. So I have that here. And I have the standard deviation for X, standard deviation for Y, but I only need the mean here. Now, if I go to regression, I'm going to select X for the explanatory, Y for the response, and then I've got my graph. So I've got my scatter plot or scatter diagram here. And then I come to my correlation, 0.945. So that is strong. And it's positive too, it's going up and it's strong. My R squared, I have it here at 0.893, and R squared is just R times R, right? So 0.945 squared, or 0.945 times 0.945. Now, to get my equation, to get my regression equation, I think the problem would ask for that. So let me go check. And then it's going to ask for the R squared too. Let's check that on that real quick. So let me go down. Yep. So it asks for my equation of the least squares line, which is A plus BX. A plus BX. So what is my equation going to be? So I go to my salt again, then go down. So my intercept here is negative 28.839. That is going to be my A. And then my B, which is my slope, is 0.7743. So I'm going to have something like this. My equation is going to be, so let me try to remember, negative 28. Let me write that. Negative 28.839 plus 0.774. Oops, sorry about that. 0.7743. Oh, what's going on with this thing? 43. X, like that. So that is going to be it. So I go back to that, and then I put that in here, negative 28. Remember, that is your A, so negative 28 point, and that's your intercept. So 839 plus 0 point or point 0.7743 x, and then that's it. I have it. Okay. All right. All right. Now it tells you to plot the point. You already know what x bar is. That is the mean for x, and then the mean for y. We did that. So put it on there. So you have 62, and then what was the other one? I think it was 19 point something. So remember, you've got to check properly. This is increasing, yes, but these two, both of them are increasing. But look at the y and x. The y, the percentage, here you have 10, 20, 30, 40. That I think is right. And then x, 40, 50, 67. X is bigger. When you go back to the problem, the x values are bigger. So that's how it should be set up. Where's the table? Yep. So you could see that the x values are bigger than the y value. So check and then make sure before you choose. And then my where is it? Yep. My y bar was 19 point, which makes sense. And then my x value was 62. So 2, 4, 6, 8. Yep. 62. So it's this one. And then you choose that. Okay. Now here you have your r squared value. You have it in there, you put it there, okay, as a decimal. And then what percentage of the variation of y can be explained by corresponding variation in x and the least squares line? This is the same thing from the r squared, but you put it in percentage. So going back to our r squared, let's check it out. R squared was 0.893. So you put it there, which is 89.3%. So you're doing both 0.893. I hope I got the value right. 89.3. And then here, what percentage is unexplained? This is 1 minus 0.893, or 100 if it's a percentage minus 89.3. Oops, 89.3. And that should give me 10.7%. Okay. And then here it tells you predict. So you're going to predict. You're going to predict with the equation. You're going to predict with the equation. And our equation is up here, negative 28.839 plus that. So predict with it. So you're going to do your y equals negative 28.839 plus, plus 0.7743 times x. And it says the age is 65. And then you solve that with a calculator to know what you're getting. And that's it. And that's about it. Okay. So keep smiling, and yeah, I'll see you. Bye.